ENVT 4402, Topic 10, Sensitivity Analysis. So far, the examples that we have seen were deterministic. In that sense, we have assumed a single number for different parameter values. However, we know that the parameter values and assumptions of any model are subject to change and error. A sensitivity analysis is a technique which helps us to investigate these potential changes and errors and their impacts on conclusions to be drawn from the model. Sensitivity analysis can be easy to do, easy to understand, and easy to communicate. It is possibly the most useful and the most widely used technique available to modelers. It helps us to establish the extent to which the outcome is sensitive to the assumed values of the input. Let's take an example which has been provided in this table here. The table shows the distribution of net present value of a hypothetical project. It shows the distribution in response to the changes in the assumptions in relation to cost and benefit. It has been assumed in this case the cost could take different values, three values specifically, like 100%, which is the base case, and 75%, which is 25% lower than the base case, and 125%, which is 25 percentage point higher than the base case. It has been assumed similar distribution for benefit, like three scenarios for benefit, 75%, 100%, and 125%. Inside the table, what we see are the distribution or the net present values. Let's take an example. Let's take a look at the middle cell, which is the for 100% cost and 100% benefit, the NPV is $75. Now, if we assume a 75% cost and 125% benefit, the net present value goes up to $105. Similarly, we can assume a very high cost, that is 125%, and very low benefit, which is 75%. Then the net present value is only $50. So with this example, what we can see is that it shows us how sensitive the outcome, in this case the net present value, is to changes in the input values, in this case the changes in the cost and benefit. However, it does not tell us what is the likelihood of an outcome is. That is, what is the chance of getting a $50 NPV versus what is the chance of getting an $105 NPV. These are often provided by the modeler themselves. So in order to conduct a sensitivity analysis, we have to go through a set of approach or set of steps. First, we have to decide on an experimental design. It is the combination of parameters which will be varied and the levels at which they will be set. The modeler, or we, must decide whether to vary parameters one at a time while leaving all others at standard or base values, or whether to examine combinations of changes. In the previous example, we varied one at a time while we assume that the other one has been kept fixed. Here is another example where we are saying that we are interested again in cost and benefit. There are three states or three possible values this cost and benefit parameters could take. There is a best case, which is denoted by M, where the cost is going to be $100 and the benefit is going to be $145. The probability of getting the best case, or M, is 60%. But there is a chance that the cost and benefit could be lower, so which we are denoting as low, or L. So there, and the probability tells us that there is a 20% chance of getting a low cost of $50 and or a low benefit of $90. Conversely, there is a chance of getting high cost and or high benefit. See, here we have assumed that there is a 20% chance that the cost would be high or $125 and the benefit would be high and or the benefit would be high $225. So given these scenarios or information, we have to calculate the expected benefit of this project. So what we can do, we can calculate the expected benefit for different combinations of cost and benefit scenarios. Let's start with low cost and low benefit scenario or combination. So the probability of having low cost and low benefit is given by the joint probability distribution, which is 0.2 times 0.2, which is equal to 0.04. The net benefit in this case is 90 minus 50, which is equal to 40, and the adjusted net benefit, which is 40 times 0.04, is equal to 1.6. Now, if you are interested to know the adjusted net benefit for low cost and moderate benefit, the joint probability of having this scenario is 0.2 times 0.6, which is equal to 0.12. The net benefit in this case is 145 minus 50, which is equal to 95. And the adjusted net benefit is in this case is 95 times 0.12, which is 11.4. Let's take the high cost and high benefit scenario, which is again has a joint probability of 0.04. The net benefit in this case is 225 minus 125, and then we multiplied it by the joint probability, which gives us an adjusted net benefit of 4. So to get the expected benefit, we have to add all the adjusted net benefits, which gives us a value of $55. So what we could see here is that instead of just taking the best case or M, we are varying the values of cost and benefit and then calculating the expected benefit. So an important issue in this case is the relative likelihood of combination of changes. If two parameters such as, for example, cost and benefits or the prices of two similar outputs, if they are positively correlated, then the possibility that they will both take on a relatively high values at the same time is worth considering. Conversely, if the two parameters are negatively correlated, the modeler should examine high values of one in combination with low values of the other. If there is no systematic relationship between parameters, it may be reasonable to ignore the low risk that they will both differ substantially from their base values at the same time, especially if they are not expected to vary widely. The second thing we have to consider what to vary. In the previous example, we just varied cost and benefit, but there are many other things in a model that we might want to vary or we might think it is important to vary. For example, the contribution of an activity to the objective, such as effort of fishing activity on the net present value of a fishery, the objective itself, like maximizing net present value versus maximizing or maintaining a sustainable population size of a fisheries, a constant limit such as the catch limit or maximum availability of resource or the carrying capacity, the number of constraints like capital constraints or water quality constraints, the number of activities, and technical parameters, which could include like biological growth function, discount rate, etc. What to observe? Whichever item the modeler chooses to vary, there are many different aspects of a model output to which attention might be paid. For example, the value of the objective function for the optimal strategy, the value of the objective function for suboptimal strategies, example strategies which are optimal for other scenarios, and or particular strategies suggested by the decision maker. The difference in objective function values between two strategies, the values of the decision variables, the values of shadow cost, constant slacks, or shadow prices in case of an optimization model, the ranking of decision variables, shadow cost, etc. These are just examples. What you are interested to observe would depend on the kind of model you have and what you are interested in. Once we run the sensitivity analysis, there are various ways to succinctly present the results. You are already familiar with how of producing different types of good quality graphs and producing summary statistics. You can also use the concept of slopes and elasticities to show the importance of different parameters. So the elasticities are the rate of change or the slope of an activity level or of the objective function with respect to changes in a parameter. They are measures of percentage change in a dependent variable, example an activity level, divided by the percentage change in an independent variable, example a parameter. So elasticity is percentage of delta y divided by percentage change in delta x. So a comparison of elasticities of an activity level with respect to different parameters provide a good indication of the parameters to which the activity is most sensitive. We will cover more of the sensitivity analysis as part of the Monte Carlo lecture. However, in a summary or in a nutshell, if the sensitivity analysis could be used in various ways, for example, to understand how robust the optimal solution is in the face of different parameter values, under what circumstances the optimal solution would change, how the optimal solution changes in different circumstances, how much worse off the decision makers would be if they ignored the changed circumstances and stayed with the original optimal strategy or some other strategy. Thank you.